This is pre-calculus on-ramps. Gotta make sure I'm recording. I'm gonna do some of the even numbers that are on completing the square. And the question says, if I can find it, in exercises 7 to 12, complete the square in order to put the equation in standard form. Identify the center and radius, or explain why the equation does not represent a circle. Remember, standard form is x minus h squared plus y minus k squared equals r squared. That's for a circle. And hk is the center. And r is the radius. You can call it the radius. I call it the radius. Okay. Now, notice, -3, -3. The number in front of x squared and the number in front of y squared, same number, same sign. They're both negative. And so I'm going to look at this little chart. When I have an equation like this, and a equals c, and they're the same sign, well, -3 equals -3, then it is a circle. So I know this is a circle. Since they're the same, I'm just going to divide everything by -3 to make this simpler. -3x squared divided by -3 is x squared. -3y squared divided by -3 is y squared, plus y squared. 27 divided by -3 is -9y. 27y divided by -3. And 61 divided by -3 is, I'm going to put -61 thirds. I don't think that goes evenly. And then I can put equals 0, or I can move this 60. I can add 61 thirds to both sides and equals 61 thirds. Okay, now let me do this. There's no x component, so this is just x squared plus half of -9 is -9 halves. So this is going to be y minus 9 halves squared. -9 halves squared is, 9 squared is 81, 2 squared is 4, 81 fourths. If I added 81 fourths to this side, I have to add 81 fourths to this side. What is 61 thirds plus 81 fourths? Well, common denominator is 12. 3 goes into 12 4 times. 4 times 61 is 244. And then 4 goes into 12 3 times. 3 times 81 is 243. So let's see, this equals 487 twelfths. I don't think that can be simplified at all. 47 isn't divisible by 3. Nope, and 47 isn't divisible by 4. It's not divisible by 6. It's not divisible by 12, so no, there's no way to fix this. So x squared plus y minus 9 squared equals 47. The center is 0, 9. That's the center. And the radius equals square root of 487 twelfths. Because remember, the radius, or this equals r squared, radius squared. Well, let me put both equations in and see if it comes out the same. Well, I've already done it. So here's the original equation. Here's the one I found. And notice, same equation. So I have completed the square successfully. You can also complete the square to find ellipses and complete the square to find hyperbolas. So I'm going to move this one over here so I can work it. X squared plus y squared minus 7x minus 3 minus 1. Okay, so again, I have 1 in front of x squared, 1 in front of y squared. They're both positive. So this is a circle. I'm going to put the x's and y's together. I'll put x squared minus 7x plus y squared minus 3y. And I'm going to add 1 to both sides. Okay. Oh, boy. They never make it simple. -7, half of that is -7 halves. I keep it as a fraction so it's easy to square. So now I know I have x minus 7 halves squared. And now -7 halves squared is 49. 7 squared, -7 squared is 49. 2 squared is 4. So I have to add 49 fourths to both sides. Half of -3 is -3 halves. So this is going to be y minus 3 halves squared. And then negative 3 halves squared is 9 fourths, so I have to add 9 fourths to both sides. And so this equals, well, 1 is just 4 fourths. So 49 plus 9 is 58. 59, 61, 62, 62 fourths, which equals 31 halves. And I can't simplify it any more than that. So center, 7 halves. Just change the signs, 3 halves. There's my center. And my radius is the square root of 31 halves. Because remember, it equals r squared. So let me just double check it to make sure I am correct. On homework, always double check. On the test, you probably can't. They'll probably say no calculator. Now they say no phones. You can't even at lunchtime. You can't even go in Texas, where I am. You cannot go at lunchtime and like open up your computer and work some math or watch some videos and try to figure things out. No electronic devices allowed except the school electronic devices. Ridiculous. At the time of this video, we need a petition to change that. You should be able to use them for doing work, schoolwork. X minus 7 halves squared plus y minus 3 halves squared equals 31 halves. Okay, see, notice it's the same equation. They're both the same. So I've successfully done it. All right, one more here. Here's number 12. 4x squared minus 16x plus 4y squared plus 16 equals 0. Well, let me try this first. Since I know this is a circle, x is 4, y is 4, the sign is the same, plus, plus, I'm just going to divide everything by 4. X squared minus 4x plus y squared plus 4 equals 0. I'm just going to subtract 4 from both sides. So I have x squared minus 4x plus y squared equals negative 4. So half of 4, negative 4 is negative 2, so I've got x minus 2 squared. Negative 2 squared is 4, so I have to add 4 to both sides. Plus, well, there's nothing with y squared. There's no y component, so plus y squared equals negative 4 plus 4 is 0. I can't have a circle with a radius 0, so this is not a circle because radius of a circle, I don't know how to write this, cannot be 0. It's nothing. It's a nothing. And let me draw the original equation and show that this is true. I don't think you could do this on the test, but for homework, 4x squared minus 16x plus 4y squared plus 16 equals 0. It's a nothing. And if I do mine, x minus 2 squared plus y squared equals 0. It's a nothing. There is no circle. See, there has to be a radius. Even a tiny, could there be a tiny radius? Somewhere. Yeah, there's, see, it drew that tiny one. Maybe I'll make it a little bit bigger, 0.001, yeah. 0.0001. See how tiny of a circle it is, but it's still a circle. But if the radius is 0, it's a nothing. It's 0. It's gone. Okay, so number 12 is not a circle. But that's some examples of completing the square. And then do they have, I want it. Oh, I already, no. Well, with circles, it's always going to be, you can always divide by that original, by whatever's in front of x, because what's in front of x and what's in front of y are the same. So anyway, that's some examples of completing the square. You can rewind the video if you want to see them again.